Welcome to Elementary Algebra. The book is by Harold Jacobs. I'm your presenter, Molly Crocker. In my presentations, I'm also going to encourage you to pick up the TI-83 or 84 graphing calculator and learn to use this tool alongside the instruction given. Let's dive in. The book is by Harold Jacobs. Well, there are a lot of algebra books out there. There's also a lot of technology that attempts to teach algebra. Some of that tech I have found to be pretty good, and I'm not against using it. So why do I advocate for a textbook, and what does this text need in our modern technical age? Let's talk about textbooks, algebra, and notation systems. A good textbook stands the test of time. An example is Euclid's Elements, a treatise on geometry that Euclid compiled about 300 BC. Translations of it are still a reference book in all of the world's major languages today. It doesn't look much like a textbook. It was more a compilation of all the things that geometers knew at that point in time. It was a reference book. Today, we have a textbook industrial complex, which requires a new edition every 4 years so that prior editions, which might be perfectly fine, go out of print and schools are required to purchase all new textbooks. With every new edition, publishers make money. Why don't we have an algebra text that's as old as Euclid? Modern algebra is a newer subject than geometry. Two inventions you'll hear me refer to often are the equals sign, which gave us equations. Equations, equals, same root word. An accountant in the 1500s was balancing the books, and his notation system was borrowed by mathematicians to balance equations. The other development was Hindu Arabic numerals, which represent the digits from 0 to 9 with a single digit. These were first shared with the Western world about 1,000 years ago, but didn't replace clumsy Roman numerals until more recently. These two notation inventions came together in the Renaissance, and modern mathematics has developed from these. I'd say that modern mathematics has shot off like a rocket from these two notation changes. Now, notation for modern algebra is still developing. There are some symbols we have left behind. There are some symbols we should be leaving behind. Arithmetic, in particular, has been slow to make some changes that would be more consistent with how we now write algebra. So, what about a standard algebra text? Has anyone written the best algebra book ever? If that happened, textbook publishers would not be happy. The new edition cycles force schools to toss what they have and buy all new textbooks nearly every 4 years. Many schools have abandoned textbooks and have retreated to electronic delivery systems, and guess what? The textbook companies now own most of these as well. They make even more money because these electronic textbooks cannot be reused by new students. They sell access to an online textbook according to the number of new students in a class each year. And I will add that the textbooks that companies or publishers generate are often rather carelessly put together. Harold Jacobs. So the book is by Harold Jacobs. Harold Jacobs taught high school in North Hollywood, California, which is quite close to Los Angeles. He saw 5 or 6 classrooms of 35 students every day. That gave him the opportunity to make observations about how kids think and learn. And in a standard American public high school, teachers have to find ways to engage students. The question, why would I want to learn this, or who uses this stuff, gets an answer every lesson. Homework sets include a brief review of concepts already learned and are meant to develop thinking in an organized manner. Every lesson is carefully thought out. I quickly learned that Harold Jacobs was a gifted instructor. He understands the task of teaching and managing a classroom and the task of learning a new way to think about the universe. That is the task of 14, 15-year-olds. After discovering his 1979 algebra textbook in 1994 and using it for a few years, I became a much better instructor. He was my teacher, even though I was never in his classroom. This is a carefully crafted textbook, written with both the instructor and the student in mind. The first edition is dated 1979. Some of the cultural references were updated for the current edition, but that 1979 book is still a great text. I have used a number of algebra texts, and this one is my favorite. It's not the one I knew when I started teaching algebra. I had to use it for a few years before it completely won me over to its approach, and I haven't found another one that I think is as good. I'm your presenter, Molly Crocker. Briefly, I got my teaching certificate in 1979, which I think I earned much later. My undergrad degree was in music with a minor in math. I incorporate music in small ways into my presentations. I do not apologize for getting math students to sing songs to help remember concepts and procedures. I think I need many more of them. I taught music and math in public schools full-time for 5 years, then took some time off to be a mom of young kids. There was some part-time tutoring in there, and I also pursued a master's degree in technology and education, which actually made me pretty cynical about the ability of technology to teach. I'm still cynical and skeptical, and it's taken me a long time to come around to thinking that someone else could benefit from my years of experience teaching math, and then how best to share my years of experience teaching math. In 1994, some homeschool students that I had tutored begged me to start some math classes. That grew into a cooperative that offered courses across the academics and arts, and I both taught and administered that for 26 years. It was a part-time job. In 1997, I took on more part-time work, teaching classes as an adjunct faculty member at the local community college. That lasted for 17 years until the principles of DEI threatened my career there: diversity, equity, and inclusion. I left before I could get into big trouble. I've seen a lot of textbooks over my career. Like most of you, I wanted to teach from a text with which I was familiar. But through my own path of instructing and thinking about teaching and learning, I found those to be efficient but dry, dull, and without any joy for learning. Homeschoolers don't show up every day of the week, and like public school students, they also need to be engaged to do well. Furthermore, they're homeschoolers, and if a small class isn't working out, they'll just leave. As I worked through a few textbooks that homeschoolers were using, I concluded that most were written by the textbook industrial complex. A publisher will put something out there just so they have something to fill up their lineup of math books to sell, to compete with other textbook publishers who have a lineup of math books to sell. They might revise it later and attempt to make it better. And they'll revise it again later so that older editions have to be thrown away, forcing schools to buy all new textbooks just because they need some more copies. When older editions are no longer available, they convene a textbook selection committee. That gives publishers a chance to wine and dine districts and colleges to choose their textbook. It's an industrial complex. The community college used the same text for all the courses with the same course titles. I didn't get a choice of text. The process of accreditation forced us to use text specifically written for adults. The Jacobs book for high schoolers couldn't be considered, so I taught from texts from at least 3 different publishers and several editions at the community college. There was one of those I liked more than the others, but for teenagers, I concluded the Jacobs text was the one that cared about kids that age. So it's a great textbook. Is there anything missing? I've talked about changes in math notation in the last 500 years. Has algebra changed? While we have firmed up topics and notation systems, the graphing calculator, which arrived in the mid-1980s for students, has most definitely changed how we teach math. And yes, there is resistance to it. But it was necessary for me to use them at the community college, and our textbooks leaned on them. I found that graphing calculators help students get their homework done faster. That makes us both happier. We could generate equations quickly, and see how changes in the equation affected the table and the graph. I can teach transformations in 30 minutes with a graphing calculator. When I was in high school, back in the days when we had to walk to school, uphill both directions, in the snow with no shoes on, we had to generate tables by hand and then plot points and draw curves. It took weeks. And if there was an error in our arithmetic, then we might not know which point didn't belong with the curve. The idea of transformations was utterly lost on me then. It wasn't until I got a graphing calculator in my hands that I caught on, and then it was fast. Should students have calculators? Won't calculators hinder their understanding of math? This is one of those objections to progress in education that has come up with every small invention. Back in 1790, just after the American Revolution, a teachers' conference publication lamented that students today can't prepare bark to calculate their problems. They depend upon their slates, which are more expensive. What will they do when their slate is dropped and it breaks? They will be unable to write. Mind you, slates were used with chalk or a piece of charcoal. These were equivalent to modern dry erase response boards. More recently, the objection to using a calculator has been, what will you do if you don't have your calculator with you? Well, you know how that one went. Clearly, I'm enthusiastic about graphing calculators. For that reason, I'm supplying how to use a graphing calculator intelligently in these presentations. This adaptation is what sets my presentations apart from others that are out there. I will add that I think Harold Jacobs was prescient about the use of graphing calculators, even though, as of this writing in 2025, he has not much experience with them. The path he chose through algebra, which I think I would call a functions approach, quite naturally allows use of the graphing tools to enlighten students about how the equation affects the graph and which equations draw which curves. If you are not familiar with these concepts, then you should have a graphing calculator. By the way, I watched as nearly all algebra texts for the adults came around to the path through algebra that Harold Jacobs set in 1979. By 2010, most every math author had conformed to that path. As a result, I'm including support for graphing calculators in my presentations. This is material in addition to the book. Now, the device in our pockets have very good calculators. Should we be using them instead of a TI calculator, which is a separate purchase? I don't care. What I do see in 2025 is an increasing number of schools that are forbidding students internet access when they walk in the door. Many child psychologists are discouraging the use of devices altogether for our young people. The TI calculators don't have internet access, so this is a pretty happy medium between no technology and internet devices with distracting games and applications. If you are in front of a group, then you can control calculator use, or for that matter, device use, by requiring students to place them face down on their desks where you can see them, so they can't be used while you are requiring their attention. I hope to supply some how-to videos for device apps pretty soon, but I think that once students see what can be done with graphing calculators, that they will find and embrace these without any help. There is one, Desmos, that is the calculator currently built into the online, standardized pre-college testing. Once students are familiar with any graphing calculator, they should be able to handle Desmos for testing. Testing companies already supply links for getting familiar with Desmos. Students can take advantage of these before they are in a testing situation. So, how will this work? For now, I'm offering just video lessons to accompany a student's study of algebra. To take best advantage of my lectures, then follow the steps on this slide. Students should preview the lesson in the text. Many may feel like they can jump in and do the homework after that, and that's possible, but you might want to watch the video presentation as well. I give clues, hints, and especially calculator goodies in those presentations. I wish there were a good way to see you while you watch these videos. Be sure to interact with the video as I request you to. If I say to pause the video and write down some responses, then do that. Be a good student. Be academically honest with yourself. I pace lectures from experience. How long does it take for light bulbs to go on? There might be a pause in the video for the brain to process and data to soak in. And that's deliberate. If I'm in front of a class, I'll wait until I can see that by the expressions on student faces or a comment someone will make. You'll need to be a good student, pay attention, replay what you didn't get, write down a question for your parent, good guide, or teacher, and feel free to email me. My email address is on the first and last slides of this video. After you've watched the video, then do your homework. Set 1 problems are review. The answers for those are not in your book. You'll need to acquire the manual for that. If you're going to be on your own, then chapter tests are also in a separate publication. Let's talk about what's in those publications. The course is for use with Elementary Algebra by Harold Jacobs. These videos are specific to that text. There are 2 editions that are available. The 1979 edition can still be found on eBay or Amazon. The used book market is the only source for the 1979 edition. The current edition is published by Master Books. There are some hardcover copies on the used book market, but the text is currently only sold brand new in softcover form, and it will last for about a year. Well, that textbook industrial complex. There are a few differences between the 1979 and the current edition. Let's talk about them. The 1979 edition contained more pages, even though it weighs less than the revised edition. Each lesson was accompanied by 4 sets of problems. Set 1 problems are review. Set 2 problems have answers in the back of the book. Set 3 problems look just like Set 2 problems, but with different numbers. The Set 3 answers are not in the back of the book. The older edition has them in a separate publication. The current edition puts the Set 3 problems and answers as a $10 download from the publisher. Both texts have Set 4 problems, which are extensions of the learning, puzzles, or brain teasers. I invite students to do them for extra credit. The answers are in separate publications, teaching manuals that are available for each edition. Are there any other differences between the 1979 edition and the current edition? Some illustrations that had fallen out of copyright contract from the 1979 edition were updated for the current edition. With very few exceptions, the exercises are identical. Let's have a closer look at what's available for each version of the text. If it was published with the 1979 edition, then everything for that edition had an Escher print with lizards on the front. There are 3 pieces. First, the textbook, which had 4 sets of problems for each lesson. The teacher's guide contained some wonderful suggestions for teaching, and also the Set 1 and Set 3 answers. The test bank had 4 versions of the test for each chapter, along with the answers. It also had some other supplementary materials to give some more practice on some difficult problem types, such as rate time distance problems. There was a publication for making transparencies for the overhead projector with roughly the same cover as the Test Masters, but I have not seen that on eBay in a while. The transparencies are referenced in the teacher's guide for that edition and are meant to help set up and teach lessons. I have included pieces of them in my presentations. As I develop this course further, I will include some of those lesson suggestions in further videos. They can be lots of fun. Here's a set of publications for the current edition. The text is softcover and contains problem sets 1, 2, and 4 from the older edition. The Set 1 answers and a test bank are in the teacher guide. The Set 3 problems and answers are in a separate publication for download only. There has been a publication titled Solutions Manual, which should work with either edition, and it shows all the problems worked out step by step. My critique of it is that it does not say what happened from one step to the next, as in 4 was added to both sides. And I think that would probably have doubled the size of the publication. I am unclear if Master Books is still supplying that publication. Cautions from long practice teaching algebra. Before you jump in, please consider a few more points. Who is this for? And there is no magic. Can anyone learn algebra from these videos? Emphatically, I say no. Remember my cynicism and skepticism about technology in education? Some very kinesthetic students need someone to figure out how to put algebra into their hands. I have not mastered that myself. I can do it in some places. In my opinion, auditory students need the sound to come out of their mouths into their ears, and just listening and watching a video is not enough. They need discussion and interaction. Students with a strong visual orientation need to learn how to think about algebra as a language. They'll see the patterns, but developing consistent use of the notation will require discussion and practice, as though one were learning a language. So, who has the best chance of making good use of this? Well-prepared students have seen and worked with exponents and square roots of perfect squares. They are familiar with formulas about perimeter, area, and volume, pi, and the formulas for the circumference and area of circles. They have used the Pythagorean theorem. They are also cognitively ready. Cognition is a brain maturity that lets us substitute a symbol, we've been using letters typically, for an unknown quantity. Cognitive maturity for algebra is like cognitive maturity for reading. You can present to 4-year-olds the basics of reading. You cannot expect them to read. Some will, most won't. But we exasperate children thinking we can teach them all to read at that age. Most kids aren't ready for algebra until they are 14 or 15 years old. It does nothing but exasperate them if you push it too early. How do you tell? They don't get their homework done because despite your best explanation, they have no idea what to do. They get less than a B on a test. The vocabulary sometimes just doesn't settle in. At the community college, working with older students who had utterly failed math in high school, I learned that if we just wait until students are ready, then they can take in the material at warp speed. It made me wonder why we think preschool will make better students. We'd spend a lot less on education if we just waited until students are ready. Please wait until students are ready. Now, if you're the student, you probably need a good guide, a warm body instructor who can see your face when you say, "I don't understand," or "I got this one wrong and I don't know why." That's the discussion part that's so necessary for algebra. If that's happening often and you find you can't finish your homework in an hour or less, and I would say most lessons will require 30 minutes or less for well-prepared students, then consider postponing this, or at least slowing it down. As administrator of that homeschool co-op I mentioned earlier, I offered algebra from the Jacobs book spread out over 2 years. I called it decompressed algebra. Homeschoolers are sometimes very busy people with a lot of things cooking. Decompressed algebra became a very popular course, and we actually ended up bringing more students through algebra on that path than we did doing algebra in a year. So, who are these presentations for? Who can make the best use of them? Well-prepared students, as discussed in the previous slide, who are good at math and have shown they can work independently. They would make good candidates for this. Parents who did well in math in high school, but, well, it's been at least 15 years since you've seen algebra. You will enjoy these presentations. First-year teachers would enjoy working with these. First-year teachers who are struggling to get everything done and would like to be able to depend on someone to know how to prep for this class. You could also be the only math instructor in a small school with 4 or 5 different classes to teach. You're finding that getting prepared for all of them is becoming overwhelming. Or maybe you're a science teacher and you know and use algebra every day. This year you've been told you're teaching algebra using the Harold Jacobs book, something you're quite unfamiliar with. Y'all have come to the right place. What is this going to cost? At minimum, everyone will need to purchase a textbook from either the used book market or Master Books. An instructor will need to acquire the publications with the Set 1 answers and tests. The cost for viewing my presentations will be $79 per semester. I'll put links to my course on the platform called Teachable below in the description for this video. Each semester will cost $79. Did you arrive here hoping to have someone else evaluate your student in algebra and teach that course? Are you, as a parent, working in some remote part of the world where you need a fully guided algebra course for your algebra student? I am open to taking on a limited number of students like this, and I would love to talk about the possibility. My contact information is on the next screen. If you have questions or comments, if you found an error, if you need help, I welcome your contact. Leave a comment below, like and share to your homeschool co-op, the administration of your school, the Facebook page your local homeschool group uses. Thank you so much for doing that. That's all for now.